Well, first of all, I'm Ryan Pearson. I work here at TechSoft 3D remotely right now, but I'm supposed to be in the Bend office, but you all know how that's going this year. Um, and I'm going to be presenting today on how to build just a sort of little demo project that we have up called Product Configurator. And that second link in the chat is to here where it's hosted on GitHub. And there's a live version of it running on GitHub pages if any of you just want to see what we're going to be sort of building. All it is just a nice little web app for letting you manipulate 3D models and put them together to build a larger 3D model. This little demo web app is made specifically with just a set of bicycle parts that you can piece together. And it's just useful as a, this tutorial is useful just for learning how to use Hoops Communicator and the Hoops web viewer, just how to actually add models to viewers, manipulate the model tree, add nodes, remove nodes, traverse the model tree, just different functionality like that. So that's why we use this as a tutorial. And the actual documentation for this tutorial, if anyone wants to follow along and access this documentation, is through the first link up in our developer docs. And I'll be sort of following this documentation to some extent. So this page up on GitHub, we have it broken up into different branches for different steps. There's about 7-ish steps for the tutorial. So if at any time you're like following along and you're having trouble getting something working or something like that, you can always just check out whatever step we're at and jump right in there. And I might end up doing that too if I have some random typo, I'm not able to find it. So I'm going to go ahead and clone this repository locally. All right. Remove the old one I have in there from yesterday. That should take a second. Oh. Is that not done? There it goes. Awesome. And while that's cloning, I'll just explain a little bit more about this. So the way this tutorial, the way it's set up, we just include some boilerplate HTML, CSS, as well as some .scs models for the different bicycle parts. And the part that we'll be working on is the actual JavaScript for building this functionality. So the HTML and CSS and a lot of the background stuff is already taken care of. If this is done cloning, I'll go ahead and open that up. And show the directory structure real quick. So right now, this is the finished version that we'll be building. So this is what we'll be working on. And that's going to be this app.js file. And this project includes, this is just all the associated SCS files. This is the index.html. I'll go over all of this more as we're actually working in it. So I'm going to go ahead and check out a branch called step 1 through 2, which is just the initial empty boilerplate code that hasn't had this built in it yet, and we're going to start there and follow through this. So start working through this tutorial. This just shows what I showed you on the other page. This just shows the directory structure. We already went over that. So I'm going to start by creating a directory in source for the JavaScript. I'll call that just JS. And then in there, I'm going to make a file called app.js. That's just going to be our application file. And let me see if I can minimize that. There, that's where. So the first thing that we're going to do in here is just make a basic class constructor. For starting our application. And then we're going to want to have that run as soon as the JavaScript is loaded. So use window on load const app equals new main. And we're going to go ahead and include that boilerplate CSS for this tutorial. And at that point, if we go ahead and try and build this project, nothing is going to happen because we haven't actually constructed the web viewer object yet. But we can see here in the HTML there's different components for our two viewers. There's where is that? That's down. There's our component container, which has ID comp viewer. And then there's also somewhere our viewer. And those just correspond to this smaller component preview up here and this larger main viewer. So we're going to have to create both of those by their ID using something like this to instantiate the viewer. And I'll go ahead and work on those. It's just going to be this dot viewer equals new communicator dot web viewer. And we're going to set the container ID to viewer and empty to true because it starts off empty initially. And then likewise, we'll do the same thing for our component viewer.
Elena, how's that going? Were you able to create that app.js and get coding?
Mm-hmm.
Fantastic. Awesome. So I think this is an important point. We're just kind of scaffolding the application itself right now so we can start adding content, but this is how you attach the web viewer to an HTML div. And in this case, two. So we have both kind of like a staging area in the top right and then a main viewer in the middle section. So we create two instances of this web viewer and then bind it to these different div names One's called viewer, one's called comp viewer in the HTML.
So after we instantiate those two viewers, to actually get them running, we need to start them both using this dot viewer dot start and this dot component viewer dot start. And now at this point, if you actually go back into your repository, I'm going to go ahead and run npm install to go ahead and install the dependencies for that repository, and that'll take a moment. We can get back to that when it's done. So we'll keep working on this while that's installing. After those are both started, we need to set the callbacks for just adding different functionality to these viewers. And these links on the tutorial here actually link to the callback section of our documentation and talking about how to use these and what they are. They just have different functionality for doing things like setting initial camera position, adding, oh, I'm going to go ahead and admit someone else to the waiting room. What does that say? I think that's Kane Hat X just joined. If you'd like to get up to speed to where we're at right now, I've linked the GitHub repository in a comment in the chat, and you can just jump to there. Clone this repository here, and then once you've cloned it, do git checkout step 3, and that should jump you to right where we're at in the tutorial if you're trying to work along with us. So anyways, back to where we're at. This is done installing, so I'm going to go ahead and run npm run build so we can see it live. And that will take another second to run too, at least on my machine. So while that's working, we can go ahead and start actually writing these callbacks. I'm going to write them first for the viewer itself. And we're going to use two initially. Model structure ready, which is just, we're going to use it to add some visual stuff to the main viewer. So model structure ready. And then another one called selection array that we will use later. And we're gonna do similar callback structure for the component viewer. So just change that to component viewer. And the initial callbacks that we're going, the initial things we're going to add to the viewer are, first we're going to set a background color for the viewer, just a nice gradient that someone thought fits the theme for this. And I'm going to go ahead and just copy that from here and add it to both.
I'm going to jump in every now and then and help you out here and add some context too. So the reason we do that in the model structure ready callback is many times we can't operate on the 3D data that's been loaded into the model until it's been loaded. So there's certain protected functions like changing the background that can't be run until until the viewer is kind of at a ready state. And so that's why we're accessing some of this kind of constructor-like behavior here in the model structure ready callback.
So another thing that I'm going to add to the main viewer, but not the smaller component viewer, is this axis triad and the nav cube. And if you see on the completed model, that's this triad for these arrows for showing XYZ coordinates, and then this navigation cube, which you can click on at different points to basically snap to predefined angles. I need to line that up with that bicycle model. So we'll add that to bolt to the viewer using this viewer.view.get axis triad dot enable. Yeah, that's right. And then do the same thing for the nav cube dot view dot get nav cube dot enable. And then for the nav cube, we're going to use a function called set anchor, which anchors it to the lower right corner of the screen, just because that's a good spot visually to keep it. Dot view dot get nav cube dot set anchor to communicator dot overlay anchor dot lower right corner. So overlay anchor dot lower right corner. And at this point, we're almost done with our callbacks for now. There's one other function I'm going to add to both of them, and that's set back faces visible to true. And what's that is doing is in case we load any model and that's had some hiccup while being converted from CAD format, so that let's say the outer face of one of the polys isn't rendering, that function renders the interior face of the poly too, so that issues like that with the 3D geometry aren't going to mess up the experience for the user. So this dot viewer dot view dot set back faces visible to true. And then I'm going to do the same thing for our component viewer down here. This dot component viewer dot view, and then add that. So that should be about it for our callbacks at this point. Go through here, that all looks good, and we can go ahead and move on to the next section. And at this point, I'm sure npm run build has been done for a while, so we can go ahead and access our project locally at localhost 8080 and see how it's looking at this point. And I made a typo somewhere, looks like. Not there. 118. Okay, I haven't saved that yet, so it's not loading. Why is that? Give me 1 second. I'm not seeing why that's not working yet. I may need to reload that.
Yeah, in the meantime, I've pushed, let's see, did I push that to everyone? Yeah, so I pushed kind of where app.js should be at this point with the construction code and the callbacks, just if in case you're following along. Great. So Li-Ming, thanks for following along as well. That's fantastic. Any questions at this point? All right, looks good so far, everyone. And Ryan, yeah, what's
Let me
it's
check
always
that.
nerve-wracking to do live code.
Yeah, so I actually tested out, Jonathan, last night. The live reloading seemed to be working just fine.
Hmm.
Comp viewer, new communicator, container ID, comp. Oh, that's all it is. I just made a typo right there in container ID. So that's why that wasn't loading. Anyways, what's that? Yeah, it looks like the live reloading isn't working on this right now, so I'll just go ahead and relaunch that build script. At this point, once that builds, the viewers should be instantiated and started successfully, so we can work on actually adding a model to that component viewer. And if we look at the HTML that's included, it has a bunch of thumbnails for different models. And each of these thumbnails has a parameter called model that refers to a specific model in our data directory. And if we go look at this, each of these thumbnails is referencing that HTML snippet that has that model parameter. So we can actually access that thumbnail value for model in our JavaScript and use it to load a model into the file, or into the viewer, sorry. So I'm going to go ahead and start a function called load model preview down after our constructor. Load model preview. And that's going to take several parameters. I'll just do parameters. Model name, which is going to be that model value I just referenced, and a default undefined transform, which that transform represents a 4x4 matrix, which defines the initial, basically the pose and shift of where a model is being loaded into the viewer. And we're using undefined initially because that's something that we'll be adding after. Well, it's undefined in this case actually because this viewer doesn't need a full model. It only need, it doesn't need an assembly of models. It only needs a single model. So it's just instantiated in the center at 0. So I'll go ahead and work on adding this function. This dot comp viewer dot model dot clear. We're going to clear that initially in case there's currently a model in it. Then we're going to set a node name equal to model dash and then the actual model name of the model passed into this function. We're then going to generate a model node ID for this model and use that using a function called create node. So this dot component viewer dot model dot create node, and we can go ahead and look at the documentation for the parameters that this create node function takes, and that's going to be over in our docs. So create node is taking the parent node ID, node name, and a bunch of other optional parameters, and we're initially setting it with just a null parent node since it's a lone component in that smaller viewer, as well as the node name. And that documentation is super useful if you're ever wondering what parameters in a function are, or what you need to add to it, how to do different things like that. So now that I've created a new node, I'm going to use this dot component viewer dot model dot load subtree from SCS file. And what that is doing is each model in Hoops Communicator is loaded in as basically a model tree, is the actual data structure describing in it. So the subtree is basically loading in the subtree of all the geometry in the set of nodes off that initial model node. And we're going to pass that a link to where our actual .scs file is inside the web app. So if you remember, like I said earlier, those are under data SCS, and that model name parameter we're passing in is actually the name of that SCS file, so we can go ahead and grab it through that name.
I think
and that, what's that?
I think it's important to kind of mention too where those SCS files come from. And so they're pre-processed CAD files that we've distributed for the purpose of this workshop. But when you go and work with your own data, no doubt you want to create your own configurator. You can create those stream cache files using Hoops Converter. That's part of the Hoops Web Platform SDK. You can download that and process your own CAD files and assemblies to create those SCS files. So this is just kind of a temporary set of data that we're using, and you're certainly able to use your own data, and that's done through a executable called the Hoops Converter. It converts over 30 different CAD file formats into a streamable form like this SCS file.
Viewer set callbacks. I'm just looking at this real quick. I don't know why that's not starting. And
we do have another question from the chat here. What type of view is created? So there, when you do call this function, so there's a couple different things here. So first, we've created a web viewer, and we will be loading in multiple models into that viewer. The viewer has, as components of it, if you look at the documentation, the web viewer object has one view that controls how data is viewed. And that one view, you can operate on it. You noticed we turned on a triad, we turned on a nav queue, we turned on backface calling. So the view determines how things are viewed. And also part of the web viewer object, there is a model which contains all of the data. And in this case, we're actually loading in multiple submodels. That's what this subtree from SES file does. So we're creating a federated model of multiple models. So we're creating our own assembly. I hope that answers your first question, what type of view is created. So it's pretty versatile. And then the second question was an SCS file. Does that work as well? And yes, the answer is yes. An SCS file, or excuse me, an SCZ file does work. The difference between an SCS file and an SCZ file, the SCS gets loaded all at once and doesn't require a streaming server. So for the purpose of this workshop, it's very simple for us to just distribute a collection of SCS files. An SCZ file is a streamable, a stream cache file that's streamable and also compressible. Normally what you need to do is set up a separate server that streams those SCZ files to your web viewer. You can still work with them the same exact way that we're working with them within this tutorial. It just adds a level of complication because you have to spin up the SCZ server, and that's fine. And we've done that in past workshops, but we just wanted to keep things as simple as possible. Fantastic questions, and I'm going to paste the code here as well into the chat that includes our load model preview function in just a minute. But great questions. Thank you so much for those.
I'm not sure why. I think I made a typo somewhere, so I'm going to go ahead and just check out that step 3 where we're at. It's running into a weird, yeah, that's not there.
And I think the last thing to mention is each time we're adding code and saving in the source code editor here, we are running npm run build, so we don't have a dev server up. We apologize for that. So every time you want to see the changes, you have to rebuild it and then have Webpack reserve it to your local host. So we're doing that each time. We almost got it.
I had it working last night.
That's how it works.
Okay, there, that worked. Sorry about that. Anyway, so this is back to where we were. Sorry about that. Technical hiccup. But give me 1 second, sorry. Yeah, so after that main constructor, I was adding our load model preview function, which I'd already done most of that, so I'm just going to go ahead and copy paste the majority of that from here. The only part that we still need to add is after that model is loaded from the SCS file, we need to fit it to the world, which is just fitting it to our viewer. So this dot component viewer dot view dot fit world. And at that point, that should be good to go. What's my missing? think I just have an extra one of these here. Right. So the next step after that is adding some functionality to what's called the pills in here. And all that is that's these components up here. And when we're clicking on them, we want that event listener to then display whatever set of thumbnails is associated with them. And that's added through these event listeners. And that isn't super relevant to Hoops Communicator, just basic JavaScript event listeners. So I'm just going to go ahead and copy paste that and move on through the tutorial. And then the other functionality that we're going to add is we want to add event listeners to these individual thumbnails. When they're clicked, we want to load a model into the component viewer. And we're going to do that through adding event listener that calls our function we just wrote, load model preview, with that model attribute that I mentioned earlier that's defined in the HTML snippet for the thumbnail. So again, that's just basic event listeners. So I'm going to go ahead and copy paste that so we can keep moving through the tutorial and hopefully get this done within the time limit, get a fully working project. That's going to go in here after, can go anywhere after the main constructor, but still inside the class. So I'll just go ahead and add it after load model preview. And then up here inside our constructor, we need to actually call that event listeners function so that it is ran when our viewers are initially constructed. And I think that about finishes up this step of the tutorial. I'm going to go ahead and hopefully build that and this time have that working. That will take just a moment.
Yeah, and I posted that page here in the chat for everyone to just pull the HTML there that populates those pills. It's too much code for me to post in the chat. There's I think like a 1,000-character limit to what I can post there. So if you wanted to grab that set event listeners code from that page, feel free to do that.
And also, fortunately, it looks like I was able to fix, I'm assuming I made a typo or somewhere. I just don't have time right now to go through that, but it looks like we have the tutorial working as it should be at this point. And I don't know if anyone else is following along, but if you're following along, do you want feel free to post in the chat whether you're able to get it running at this point or whether you're still working on it. I'd like to make sure I don't keep steamrolling past through everything before anyone who's trying to follow along can stay caught up. Let's see if I can open the chat here. No, that's not what I want. Weird. Are you able to see the chat, Jonathan?
I am. It looks like Elena says she's all caught up. Frederick had to step off. Li Ming, how are you doing? I think we're doing pretty good. I'm following just about a step behind you, but that's just fine.
All right. I'll go ahead and move on to the next step now that we have these parts of the functionality working. Is this, I think it's, at this point we need to actually add components that we've selected in our component viewer to the larger assembly view. So we're going to do that by adding an event listener to this add to build button here to actually load whatever model is loaded into the component viewer into our main assembly viewer. So we'll create that event listener in our set event listeners function. I'm going to go ahead and add that to the end of it just to keep track of where we're working. So document.get element by ID add to build button. And when that's clicked on click, we want to go ahead and add that in new component to whatever model we have. So the first thing I'm going to do is I'm going to check that there's currently a model in that component viewer. So I want to check the component type is defined, as well as selected component and also selected component name. And if all three of those are defined, then we have a good model. If any of them are not defined, then there's something up, probably just an empty viewer, and we need to alert the viewer, the user, that they need to select a component first. So no component has been selected to add to the build, and then return from there. And if we make it past that check, then there is a component in that viewer, and we can go ahead and start adding functionality to add it. But first, I'm going to bounce back into the beginning of our constructor and add a new map called build selections. So I'll just add that at the very beginning. And what that is that is a map mapping each part of the bicycle that we're building to the specific component that we're selecting to set as that part. So like we're selecting a specific frame, a specific seat, any part that has different options. That map is going to be between something like fork or front wheel or frame and the individual parts that is selected as our frame. So once that map is initialized, then we can start interacting with it and using it as we build our model. So back in our add to build button event listener, we want to let model equal this dot viewer dot model, and that's just getting our model as a so that we can manipulate it. And then we're going to add a new pair to that build selections map that we just defined. So build selections dot set, and then map this dot component type to this dot selected component. So that's mapping the component type, like I said earlier, to the actual component that we're including. And once that's done, we need to get the frame that we're using. And the reason for that is in the bicycle model, the nodes of all other parts of the bicycle are children of the frame part of the frame, since that model has sort of this tree-based directory structure. Tree-based structure. So we need to make sure that there is a frame for the model. If we're not adding a frame, then we need to alert the user and go add a frame first. So we're letting frame base equal this dot build selections dot get frame, and then checking if that's undefined. And the reason that this works is even if there's no frame in the main viewer yet, we just mapped the component type and selected component that we're adding. So whether there is a frame in the main viewer or there's a frame in the component viewer being added, it is now in that map. So the only way it can still be undefined is if there's no frame being added or currently existing. And if that's the case, we need to tell the user that needs to be done first. So alert, please select a frame before adding other components. And if we make it past this point, then we should be set up to actually start adding models to that viewer. And we're going to start doing that. First, we're gonna set a node name just like we did earlier with our component viewer. So const node name equals model dash plus this dot component type. And component type was set to that model value earlier in our event listener, which called the load model function. And once we set that node name, we need to basically get the current full existing model tree in the viewer. And the way we'll do that is by first traversing up to the root node on that model's structure using model.getAbsolute root node. And then we'll use model.getNodeChildren to get all the children nodes off of that root. So the combination of those basically travels up the model's tree to the root and then grabs everything that is a child of that node. And that should return the entire model as a component subtree that we can manipulate. So component subtree equals model.get node children of model.get absolute root node. And that should give us our full model tree. At this point, we need to do one final check related to if we're adding a frame. If the component subtree's length is 0, that means the component subtree is currently empty. The main viewer is currently empty. And if the component that we're adding is a frame, that means we're just adding a frame to an empty viewer. In that case, the syntax is pretty simple. It's just like when we were adding models to our component viewer. So if component subtrees dot length equals 0 and this dot component type equals frame. That's simple enough. If that's the case, we just set our model node ID using that create node function from earlier of null and node name. And then we just call load subtree from SCS file again with our model node ID and the path to the model. There's one slight gotcha here is because the syntax here, because we're using this parsed variable, we need to use backtick instead of forward tick for that to be interpreted correctly. So that, and then data SCS, and then get our component type, or sorry, selected component. So this dot selected component, and then finally dot SCS. And that selected component variable should still be the model parameter that we set it to earlier when we initially parsed that HTML and got the model value from it. So that should get us there, and that should be sufficient for handling adding just the frame to that viewer. Now, if the component subtree.length is not 0, if there's geometry already in the viewer, and if we're not adding a frame, so if not both of these are true, then we're going to have to do some more complex manipulation. We're going to have to iterate through all the nodes in that subtree. So I'm going to use a helper variable here. Sorry, mouth is dry. I'm going to use a helper variable called node exists and set that to false initially. And then I'm going to traverse through that tree, the component subtree that we grabbed previously, and look for a matching node in it. So I'm going to iterate through every node ID in the component subtree and check if the model name, or sorry, node name, not model name. So if model.get node name of whatever node ID I'm currently on equals node name, then that means that node already has been created in the tree. So basically what this is doing is it's traversing through every part of the bicycle, frame, front wheel, back wheel, seat, handlebars, etc. And it's checking, oh, are there already handlebars? Is there already a seat? Is there already whatever? And if there is, then it sets node exists equal to true. Then it deletes whatever is currently in that node. So model.delete node at node ID. And then it needs to update the node with the geometry and the model that we are adding. And I'll do that. I'm going to use a promise array, so this can run asynchronously, so it doesn't freeze while that model is loading. And that doesn't really matter too much with smaller models like this, but if you're manipulating very large models with like lots of parts, that can matter. So it's better to do that asynchronously. So I'm going to create that node as always. Model.create node null node name and node ID. Only difference is this time I'm adding this parameter node ID because I'm creating a node with a node ID that already exists. It's already been created in this model tree. And then I'm going to push the load subtree from SCS file onto that promise array, so it can actually load in that new model in the background. And same as before, just model node ID, and then backtick data SCS. I think this dot selected component and dot SCS. And that should push the loading of our new model onto that node, onto our promise array, so we can go ahead and return, and that will continue to run in the background until it's done. And so this handles if the node ID already exists. The final case we need to handle is if that node does not exist yet. So that's inside this bigger else after our for loop. So after we iterate through there, we check if node exists is true. And if node exists is still false, that means it never found a matching node and we need to add that node. If that's the case, it's pretty simple. Just model node ID again equals model.create node of null and node name. And then like up here, this dot viewer dot model dot load subtree from SCS file and our model node ID again. This dot selected component dot SCS. And that should handle any type of model being added to our viewers. And then finally, I'm going to add this event listener, which basically it's looking for if a component type is being changed and resetting it. And I'm going to add that. I think that needs to be after this event listener. So I will add that right here. And at this point, if I go ahead and build this again, it should be able to load the rest of the geometry into the model. So give that a minute to load. It'll take a second. While that's building, does anyone have any questions? Oh, yeah, so I made a small typo. I needed to use the word new when I built this map up here, because I'm instantiating a new object. So, I don't know. Yeah, that live reloading isn't working for me. It might be working for all of you, but either way, I'm gonna reload that and keep moving on to the next step while that builds. So we've added all the functionality for actually, this is the wrong step, sorry. I need to go to incorporating model relationships. And I need to show where this is currently at, and you'll see why in a moment. There it goes. Which line is that on? Okay, that looks like it's on the wrong place. So I think somewhere I have a typo, so I'm gonna go ahead and just, since we're running a little bit short on time, I'm just gonna pull the completed step where I am at, since that'll be faster than digging through and debugging for whatever typo I made in this project. So we should be done with step 5, I believe. And I'm not sure what the issue was with that. It looks pretty much the same to me, but
How's everyone else doing? That was a lot of code that we ran through. Yeah, so
are
I
you
got it.
able to see the chat, Jonathan?
I can, yeah.
Okay.
It's pretty quiet, but that's fine. I was able to get mine, catch up with you and get mine running just fine. So yeah, it's always nerve wracking you are kind of writing a lot of code there, which is great.
Yeah. I'm guessing I just made some old typos somewhere in there, but it should be working now. I just want to wait for that to build so I can show why it's important. Give some context. Right. Oh. So it looks like it is currently working now, and I'll show you why the next step is important. So we're able to add different components to the main viewer. However, they aren't placed in any meaningful relation to each other yet because we've been only adding the geometry. We haven't been specifying where those nodes need to be, and that's what this next step in the tutorial is about. So they just get kind of placed somewhere random at the moment. Or even worse, the scaling is crazy and way off. And this happens usually, my understanding is because different CAD model formats can use different underlying units for measurement, and those aren't necessarily specified when the model is converted to SDS from various CAD formats. It can, many different like 3D model formats can be converted to it, and they don't all have consistent units. So I'm guessing this is something like inches to meters in two different models or something like that. And both of these issues, scaling being off and initial position of nodes being off, are what this next step handles.
Yeah, and if the units are available in the original CAD file, we can and will respect them. You can turn that option on and off. But because this data came from a variety of different sources, they aren't located next to one another in the same type of orientation. Some are part of an assembly, some were just single files. And so we did have to go in and tune the relationships, the spatial relationships between them. And we did that more or less by hand. We have some code that allows you to snap different parts to surfaces, but that's not core to the Hoops communicator and the Hoops web platform. So we do need to go and change those units. So this is a step that may or may not be necessary depending on where your data is coming from. So if it is coming from a single source of truth assembly with just different configurations as part of the CAD assembly, that's perfectly fine. But this is kind of a nice little step that allows us to tie your code in with some business logic in terms of relationships between objects.
Yeah, thanks for that, Jonathan. That kind of explains that a little bit better than I did. So I mentioned earlier that our load model preview, it was setting transform equal to undefined, and I mentioned that that was a matrix. So that's what we're actually going to use now to basically scale things and move things around to be in the correct position. Is we're going to use different matrices that define initial positions and poses for the different parts of the bicycle relative to the frame. And those are included over in data as attach points or attachment points.json. You can see this is a set of lists of parts, and for each of them an associated list of 16 numbers. So that 16 numbers are actually a rolled out 4x4 matrix that, like I mentioned, defines translation as well as rotation in 3 dimensions. And those are for defining an initial pose for each part relative to its parent, the parent node. And that's something that kind of holds true throughout a lot of different CAD formats. Is each node in the model tree can have an associated transformation matrix that defines its pose relative to its parent node. That's basically how that how 3D geometry is actually incorporated into a tree object and visualized. So what we need to do here is actually get this attachment points.json and basically break it up into a set of 4x4 matrices associated with each part. So we're going to fetch that from its path, which is data attach points.json. And then once that is fetched, we're going to format that response as JSON. Check if that response was returned correctly. So if resp.ok, and if so, we can start parsing that JSON. Using .then on our data. Do I have a typo? Oh, right. I need to convert the response to JSON first. That's right. And then we can iterate through that. I'm going to define a variable called node data and let it equal data dot node data, which note, this got me a couple times. This is capitalized, whereas this is not, because this is pulling it. I think the reasoning is because that's a JSON object, and this is just a variable storing the data. And it's referencing this node data up here. So then we're going to loop through that. So let num entries equal node data dot length, number of entries in that, and we're going to loop through that. Let I equals 0, I less than num entries, and plus I, iterate I upwards. And one other thing I need to do is I'm going to define another map up here after build selections. So this dot frame attach points equals new map. And just like we use that map to store the relationship between where a node is, or what node it is, and what models attached to that node, we're going to use this frame attach points to store what matrix transform is associated with each subpart on a frame. So as we loop through here, we're going to add a new mapping, a new pair to our map. This dot frame attach points dot set node data at I dot, what does that say again? Model name. And map that to node data at I. So we're mapping each of the model name is the actual name of the specific frame, and we're looping through and we're watching each of the parts of that frame to the associated transforms. So the reason that we have to have separate transforms for different frames is the frames are shaped different. So the front wheel is going to be in a different orientation, a different location in space relative to root on this frame called Jabberpeggy. I'm not sure about the names. Mountain bikes have weird names. Versus Overbiter. So for each of these frames, we need to have all of these associated transforms. And this is where we're mapping those together. And once those are mapped, that's about it. We just need to, if the response is not okay, alert the user. Alert no JSON found. This model. And that should be about all we need to do up here. Next, we need to go back down to our add to build button and start working on functionality to actually transform that stuff. Well, first, actually, I need to add one more callback in model structure ready for both of our viewers. And that's this model.set enable automatic unit scaling to false. And basically, we're telling Hoops Communicator to not rescale that model by whatever unit it thinks it's using, and instead scale it however we manually told it to scale it. And that should fix the parts being crazy sizes relative to each other. So back up in our callbacks, I'm going to add this dot viewer dot view, or sorry, dot model, not view, dot set enable automatic unit scaling to false. And then likewise up in our component viewer. So this dot comp viewer dot model. Don't need to repeat that. And that should be enough to fix the weird scaling. Then back down into the add to button event listener. We need to add some functionality for adding those transforms. And we're going to do that by first getting the raw matrix data, that list of 16 numbers. And we're going to do that right, I believe we want to do that right after we get the component subtree. Let me double check that just in case. Right, so give me 1 second. I misremembered where that needs to go exactly. It probably doesn't matter exactly. Oh yeah, it is. So right after this component subtree is when we need to add that functionality. So first we're going to get that raw matrix data with just call that raw match data equals this dot frame attach points, our map that we created, dot get, and then first we're going to pass it our frame base, since it's going to have a separate map for each of those 2 frame or however many frame bases in our attachment points. And then we're going to pass it the actual type of component. So component type. And that should get the associated transformation matrix associated with whatever type, seat, handlebar, whatever, for a specific frame base. And then we're going to use this function, which is slightly more convoluted. I should probably break that up into multiple functions, but let transform matrix equal. And first, we're going to add some functionality to check if it's a frame, if we're getting the transform matrix for a frame, in which case we just want it at root. We don't need a transform matrix. So this dot component type equals frame. And if that's the case, set our transform matrix to null. And then if it's not a frame, then we're going to set it to this function, communicator.matrix.create from array object.values of raw matrix data. So that's just an included function with the communicator matrix class that converts a list of numbers, an array of numbers, into a matrix. Dot create from, create from array. Array object dot, that was object dot values of raw mat data. And that should be enough to actually get our transformation matrix that we can now use. And now we need to use some more interesting functionality to actually apply this. So first we're going to check if the component, again, this is inside our add to build button. So we're going to check if the component that's being added is a frame. Because unfortunately, if it's a frame, we need to actually update the transform matrices for every node in our build. So we're going to push another task off to that promise array. Promise array.push model dot set nodes visibility of traverse up to the root model dot get absolute root node to false. And what this function is doing is, while we're basically traversing through this array, through this tree structure of models and shifting stuff around, we don't want that to be visible to the user. So we're going to initially set the node visibility for the entire model tree to false, and then retoggle that once that promise array is complete. So then we're going to snag the component subtree again using let component subtrees equal model dot get node children of model dot get absolute root node again. So again, we're just grabbing that component subtree so we can manipulate it and iterate through it, different things like that. And then we're going to loop through that again for let node ID of component subtree let node name equal model dot get node name of node ID. We're grabbing the actual node name, and then we're going to use let node type equal node name dot slice at 6. And what that is doing is we're taking this node name declared earlier, and we're getting this dot component type just by slicing off the first 6 characters. And that gives us the component type, which we can then actually use in other functionality to get the associated type. So if that node type equals a frame, then continue, since we don't need to actually do anything to that. If it's not a frame, we're going to get that associated transform from our attachment points map that we made earlier. So raw map data equal this dot frame attach points dot get frame base. We need to make sure we're getting from the set associated with our frame base, and node type, that value that we just got. And that should get us our actual matrix data. And then down here again, we need to do what we did earlier and convert that matrix data to a transform matrix. So let transform matrix, it's not capitalized, equal, and we've already determined it's not a frame because this continue line would have skipped over this otherwise. So we only need communicator dot matrix dot create from array of object dot values of raw mat data. And that should get us our transform matrix. And then finally, after all of that, we can actually apply our transform matrix using, I'm going to push this onto the promise array again. Promise array.push model.set node matrix is the function we're using, which actually updates that matrix of node ID and transform matrix. So I'm running slightly behind schedule just because of that technical hiccup earlier. I apologize for that. So if anyone has to go, feel free to. I think we just reached the 90-minute mark. But otherwise, I can continue through this tutorial for anyone that wants to stay. We're pretty close to the end at this point. Once we get past these, well, not super close, but it's not a whole lot of functionality. Once we get through this, you have the majority of the project working. So I'll just continue working through this. Once that promise array is done, promise.all, we're going to actually first do some bounding stuff to make sure everything is oriented and fully in view of the viewer. So viewer.view.setBounding calculation ignores invisible to false. And what that is doing is it's making sure the bounding can be shifted to fit the model that's currently invisible, because we set it to invisible earlier, so all this would not be visible to the user while it's happening. And then once that is enabled, we're just going to fit it to the world again. So viewer.view.fitWorld of the origin. And then we can finally, excuse me, sorry, set that all to visible again using set nodes visibility of everything from the root model.get absolute root node to true. And that's right. Okay, and just to recap, what this is all doing is, if this is a frame, this is looping through the entire model tree and updating that transform matrix for every node. Now, if that is not a frame, actually, I think we're getting closer to being done than I thought, because this is just showing what our functionality should look like now, which we're mostly done with this. The only thing I think we need to still do right here is pass the transform matrix that we created into model node, into create node. So there's a couple places where we need to do that. I believe the first is down here, create node null node ID, and I'll add that transform matrix. And then again right here, which is if node does not exist. That can be shifted. So that needs to be null, because if it doesn't exist, there is no node ID yet. And sorry, I know that's a lot of code to go over, but that should be enough to basically iterate through that model tree, get everything scaled and oriented correctly. So I'll go ahead and try and build that. And fingers crossed I haven't made some random typo somewhere. If I have, the code is functionally identical to the step 6 branch. I'll just go ahead and check that out. And we should get this working model. But in the meantime, while that's building, the final step in this project is pretty simple relative to the rest of the project, and that is just adding an event listener to our reset build button, which is pretty simple. All we're doing is clearing this model, as well as taking all of these elements that are set and setting them to not selected, and then clearing our build selections map. We don't need to clear our frame attach points map because it will never change unless you add your own functionality to this project and have different model parts, different frames. So I'll go ahead and look at this real quick. Load that. And I'm guessing, yeah, I made a couple typos. No data isn't defined, so frame is undefined. So I'm just going to go ahead and check out that next step instead of debugging that, because I know we're short on time. And you can see basically it's exactly what I just wrote, just with additional comments and no random typos somewhere. And I will start that building again. In the meantime, we can go ahead and add that final event listener real quick, which I'll just go ahead and add that at the end after the other event listeners, which is pretty simple. I already explained that, so I'll just go ahead and copy and paste this from the tutorial page and add it right here at the end. I think is probably a good spot. And then finally, all the this function is a function which when the entire window of the web browser is resized, it just resizes the canvas. So without that, if I like grab my browser and resize it, that's gonna compress or warp the viewer. This just sets it so that the viewer will be resized to fit whatever window size once I rescale it. And I'll add that down here as well. Meantime, that's done building, so we can go check out where we're at, hopefully. And we're able to add a frame. Parts are added in the correct pose relative to that frame, and then if we change the frame, that pose is updated to reflect the new frame. And you can see that sort of flash of disappearing very briefly. That's it disappears at that point where we set it to invisible, and then it's reappearing once the relationship between position for all those parts is done loading. So you can see for something of this size, it's pretty much immediately, you can barely see it, but it's better to set that to invisible and do it asynchronously anyways, because once you scale that up and do larger models, it's better not to have that be a visible part of the functionality. So finally, we're able to add wheels, which were the part that uses a different unit scaling. And now the manual scaling that was initially done to these parts is not overridden by the automatic unit scaling to whatever units were initially used. And this is loaded in, I think, if everything is working, I think that's about it for this project, because we've added everything through the final step. Added, oh, let me check that reset build button. So I still need to just rebuild that on my side. But that about ties this project up. How are you all doing? I see everyone's still here. Is everyone at a pretty good point in this project? Are you able to get it building, get it running, and get the functionality working on your side?
This is Ellie. Yeah, I followed along fine. I had one question.
All right.
In this example project, we have the node attach points in a JSON file. Do you have any thoughts on a practical implementation of this and where and how you might gather node attach points from components in an assembly?
So these node attach points were made by whoever assembled this bicycle model. There's built-in functionality in Communicator to actually like manually move a object, a model relative to its parent object, and then get that transform matrix that that you basically programmed into it by moving something, because moving anything and rotating it in space is going to have an associated linear transform that moves it there. Jonathan, you might be able to clarify an answer to that better than I.
Yeah, so we did have to manually move parts because they didn't exist in the same space in the same assembly. Normally, when you have a large assembly that was designed as a project, if you load the project file, let's just talk for instance about a SolidWorks assembly. So you have your assembly file, and you have maybe subassembly files, and you have a part file. You have all of that attachment information when you load the whole assembly, and you could cache that for each of the parts. So you can actually walk down the assembly tree, and it actually might, I'm trying to think, I'll have to follow up for you, but we might actually do that for you and push it to an XML file as an option when you do the conversion. And that would allow you to move parts around and kind of understand where each part sits in the assembly relative to the origin. And so you get those attachment points. When you have parts coming from different places, you don't know where those positions will be, and it has to either be done manually or using some sort of intervention, like maybe some machine learning, but just some more contextual information that will place the parts. I'll have to check though about that XML file for you, and if we
Right.
add the,
I think
yeah.
yeah, the transformations relative to this for the subcomponents of an assembly. I do know that we get those. Yeah, I'm just thinking creatively on when you have, say, all these different options and they don't necessarily exist in an assembly, how you might tag those points. But anyway, thanks. I think that helps.
Yeah, to further kind of walk down that that path, what we've done is you can, like a CAD system, you would constrain one part to another. And so you would find concentric circles. So then all of a sudden you constrain them to an axis, and then either planes that are coherent with each other or a coherent plane and then offset. And so then you would create some user interface that would allow you to, let's say, easily create those attachment points.
Okay, thank you.
Yeah, great question. All right, we have another question in our chat. How do you find the matrix, transformation, rotation, scale value, using what kind of tools? Ryan has here, he's double clicked on a part of the fork assembly, and he's attached a set of handles. So that's another good question. He's attached a set of handles. And Ryan, if you would, why don't you just, or you've moved some of that stuff around. So using those handles, then this is how we created our attachment points for this project, is we just manually placed the part at a particular location, and using the selection array, you can query what's currently selected and how much it's been moved. So you're able to output the transformation matrix for that selected part, and we save that to a file and then reuse that. So good question. So this is the tool we used.
To build on that, Jonathan, that's actually something that's not included in that tutorial up on the docs, but we can go ahead and add that real quick. It's pretty simple functionality that's up in this set callbacks handler up here to enable the ability to move all these parts around and rotate them. We need to fill out the functionality in this selection array. So we're going to do if selection events dot length equals 0, return, and let handle operator equal this dot viewer dot operator manager dot get operator. A lot of syntax here. Am I spelling that right? Yeah. Of communicator dot operator ID dot handle. Make sure that's all correct. And then handle op dot add handles of selection events of 0 dot get selection dot get node ID, and then finally handle operator dot show handles. So I'm not as familiar with this functionality in operator syntax as Jonathan, but I know that if this isn't part of the tutorial, but if I add this and run it, if you all add that code and run it, you should have the same functionality here on your locally running viewers to manually move parts around relative to their parent node. And if you repeatedly click on it, basically, you can see here I kind of broke this wheel apart because each of these models is made of a bunch of subparts in a component tree, just like the entire bicycle is a component tree. You can traverse up to farther and farther root nodes by repeatedly clicking a model. You see if I click that long enough, I select the entire thing. And then at whatever selected component you're at, you can change. Basically what I'm doing right here is I'm manually changing that transformation matrix for some node, some subnode in this model tree. Looks like it's about halfway through this actual fork right here. And I think once you do that, there's an actual method to grab that modified transform array that you just created. I don't remember the name of that function. Do you know what that's called, Jonathan?
Oh, I go search the docs for that. But yeah, you ask for the modeling matrix on the node. So like get node modeling matrix, and you output that to the console or to a file to get kind of how it's changed. Let me go see if I can find that.
Which that's now enabled. If you followed along, I can go back to that code I just wrote, but that should be working on all your local copies. This selection array callback functionality. And it's a combination of that and an actual function to get that matrix that should give you a matrix like that, which you can then could add to a JSON attachment points file like we have in this, or to an XML file, which Jonathan mentioned. I think you can automatically generate those.
Yeah, I'm gonna push that to the chat here.
Awesome.
And the function is on the model. It's get node matrix. So for the node that you have selected, it will give you the modeling matrix that is associated with it. So if you change it in space, that'll update the modeling matrix.
Is it, you said get node matrix?
Yeah, get node matrix. It's on the model, so you'll have to walk down to the model from the web viewer, and you have to give it a node ID as well. So
okay,
you would get the node ID. Let's say you know it or whatever has been selected. So selection in the selection set will give you a node ID, and then from that node ID, that identifying it's a unique integer that identifies that particular node in the assembly tree. You then use that node ID to output the modeling matrix.
which I imagine it's not implemented as part of this tutorial, but I imagine it would be not too hard to actually add that functionality, maybe add another event listener and add some functionality to this selection array to actually get that from that whatever specific node you have selected and just manually modified.
Yep, maybe as a follow up, we could provide that to the attendees, and yeah, I think that'd probably be a good one to do as well. Any other questions? We really appreciate your time today, everyone.
Yeah, I appreciate everyone staying after the allotted time.
But also, I'm really interested in what you're going to build, and we'd love you to fork this GitHub repository and do something interesting with it. And we'd love to highlight that in some of our communications to our developer community. So I'd love to check in with you in a little bit just to see if you were able to build anything from this. And of course, we're happy to help you with anything that you need assistance with. If there's no other questions, I think we'll say goodbye for today. Thanks, Ryan, for working through that. That was a body of work, and well done. We do really appreciate your effort in doing that.
Thank you all for attending.